Looks like we're live. Okay, so what I'm gonna do, I was thinking about this, I was getting my coffee, is we're going to start from the beginning again, just so that this doesn't look more crazy than it is. So I'm gonna do the exact same thing I did last time. Pass 5. And I feel like this repetition is nice. Okay, so to hell with that code. One thing I wanted to do is I wanted to okay, so what is it that we're doing? First, we basically are making a tree of strings. So we're saying enum expr, and it can take a sim, which has a string on it, and we can have a list, which is a vec of expr. So now we have a tree. And then we need to derive our, what is it? Derive clone, hash, and is there one more? Debug. Okay, so now we have an expr that we can print, we can compare equality, and we can put it in hash maps. So that's great. Then we made some helper functions. So the helper functions were function sim s, which takes a pointer to string and returns an expr. And that goes expr sim s.to string. And that's it. Then we had a function list, which I'm not going to implement because it wasn't as useful as I thought it would be. So we're gonna actually make list take strings this time because it seems like the easiest way. So this is going to be s of type, and I think we can do pointer to slice of stir. And then this goes, you do this. Okay, well then I don't care. Vec of pointer to stir. And then we're going to say s.iter.map. Oh, we'll call this stirs. Stirs.iter.map s sim s dot collect. What do we say? We say vec of underscore, and then we say expr of list. That. Cool. So now we have some helper functions, so we should be able to do stuff like list of f of x. So now let fx equal this, print line fx that, and then we should be able to run. Cool. So now we have an expression type and with lists. The next thing that we did was we introduced the idea that there's a special symbol called blank that matches any expression. So we define this function called function myMatch that takes an expr of type expression. It takes a pattern type expression and it returns a boolean. And what we did is we match expr pattern, and then let's say blank goes to do, and we said if we get a sim, an expr sim of e, an expr sim of p, then what we do is first we check if p is equal to blank, return true. We can just say true. Else, e compare with equality. So now we're saying, okay, so if you don't have a blank, then you need to check if, x on the pattern is actually x in the expression. Okay, so that's all good. Then we said expr sim e expr list p's, and so now what we're saying is this is just false, because there's no case where a function call like this should really match just X as a symbol, or F or whatever, even blank being called. Because what we're saying is that blank is just a special symbol, not yeah. So why is this not good? Oh, I think that's just a comma needed. And now we're saying what happens when we get a list and a symbol. And I feel like I should put this case up here, actually. And we could just make this an underscore. Okay, so this is going to be ease, expr list p, or sim p's. Cool. So now this function, we're saying the exact same thing as here. So we could actually make this a blank. So we can remove this arm. We just call this expr is equal to pattern. Okay, so then this arm is already captured by this. And we can actually make this all else goes to false. So we can remove this, and now we're going to take this as just list. So now we have the two list case. And what we said was basically since blank is a single match, so it will match exactly one expression, then we can make an assumption about the lengths of the lists on both sides. So we can say if es.len not equal to ps.len, then false. Else, we can do for ep in es.iter.zip keys, if not my match of ep return false, because if any of the sub expressions don't match, then the whole thing doesn't match. And then otherwise, we can just return true. And I think we have to clone these guys. But I think, isn't there something like into iter that will give me the actual thing? Right. Oh, interesting. Okay, so we do have to clone. Clone. Where did it get moved? Okay. Wait, what? Interesting. Okay, I don't remember having to do that last time, but that's fine. Okay, so now we have a basic pattern matcher that works with blanks. And it's, whatever, 25 lines of code. So basically, let's just write some basic test cases. Should I? I don't know. When I was watching the VODs, the test case writing was kind of boring, but it is useful. So I'll just copy them over and make sure that they work. So let's look at cast 4. We're just going to copy the test cases, make sure that everything works as expected. Is there anything else we need? I think that's it. So we can close this guy, put this in here, and then the only thing that we need is we need to change this to list. Cool. So that is great. So all the test cases worked as expected. But now, what we're going to do is we're going to expand the functionality of blank to be a little bit more useful after these messages. Yep. What we do? What we do? What we do? All right. Cool. So now what we're gonna do is we're gonna switch from thinking about blank as just a symbol, but blank as a as a 0 or 1 argument function that basically. Why do these test cases look so nasty? Well, whatever. We're gonna change this to end up looking like okay. All right. So instead of blank being a symbol, here we're actually just gonna end up returning equality. But then here in this thing, what is it that we need to do? We need to look. Well, let's write it. Let's write it again. And so what is it that we need to say? First we need to say blank goes to false. Does everything go away? I don't see what's wrong. Okay, well, anyways. E for sim P. What we're just doing is we're going right back through doing the whole thing over again, but we're thinking about, in this case, our wildcard is no longer just a symbol. Now we have blank is a 0 argument function. So expr list, you say list back blank. Okay, so now we have a blank. So here we have just symbols. So we do E equal to P. So that's all we have. Why is this not? Oh, is it because of that? I'm so confused. Maybe we don't need this. Oh, yeah. Okay. Syntax. Anyways, now we're going to do expr sim E expr list P. P's, right? Because we have multiple of them. And what we're going to do is basically we're going to say if P is 0, so if the first element of the vec is equal to the sim blank, then we know that we are at the case where we have something like F matching with blank. Then what we want to do, just for right now, and I'm going to revert this soon, is we're going to assert that the length that ps.len is equal to 1. Then we're going to return true. Else, I think it's just false. And the reason why it's false is this arm, because it's trying to compare a symbol to a list. So what I'll do right now is just, we will remove when we start introducing heads. Head in blank. Okay, cool. So then what's our last arm to do? Expr list ease, expr list ease. Okay, so what do we need to do here? Well, we need to, I think it's just the exact same thing here. I think that this is all good. And this just need to be my match too. And now we're just going to change this and see if our test cases pass. Oh, well, they won't, because we need to make. Right, we're going to do this, but we're going to actually list them, list spec. Cool. So now wherever we see blank, we're going to change this to blank. Similarly, yeah, we might want a helper function, but okay, fine. So we'll make I'll just call it list e, and this take e is back of expr, returns the expr, and it just calls expr list of e's. So then here, instead of this one, I could do list e vec of sim that list vec of, and actually I think I just put blank in here, so that'll make that easier. Blank dot clone blank. And so now we're going to compare FAB to list E. So let's try to run it. Cool, what goes wrong? Case 4. So what is this case? Why is this going wrong? Well, we have the list 1, and we're matching that with the list blank. And the reason why is because we end up going to, in here, iterating over that. Yeah, so what we need to do is we need to check in there whether or not it's a blank. So similarly to here, first we want to check if P P0, well, I guess first we need a match. We need a match on P. PI pies, I don't know. So we need to catch this before we recurse. Otherwise we do nothing. That's not right. Let's try it again. Oh, because I have some random thing in there. Wait, what? I'm just cloning all over the place. Okay. So we're still running into that problem. Let's debug. So the first thing we do is we get to I think we just need to move this actually out here. Cool. All right. Yeah. So that was just me being weird. Okay. So now we're going to introduce a new function that's pretty important. It's called head. Returns an expert. And we're going to match E. Okay. So we're going to say we have an expert sim blank. Then we're going to return the expert sim of its own name. So this is sort of like what's happening here is, well, I'll demonstrate in here. But if I do head of head of x is just some unknown symbol, we get the symbol back. But if I give head of x, then I get x. So it's basically looking at the list structure, but when it gets an atom, it sort of returns the symbol that represents the name of that atom. So here, and I can just call my handy sim sim. Okay, then otherwise we get expert list ease, and we return ease 0. That's all we do. Yeah, see, I feel like I'm doing something weird. I'm just placing clones all over the place because I don't really care about this. Okay, so now what we're going to do is we're going to remove this assertion, and we're going to say if equal to 2 and head of, or no, and PS1 is equal to head of E. I think we want to do this. So if the length is 2, yeah, let's just write it. I'm gonna. Okay, so, all right. So we found a blank. Now we want to say if ps.len is equal to 2, then we say let p head equal to ps of 1. Okay. Then we want to say, does the head in this second thing? So now we're saying this has sim at the back of it. I'm going to say if p head is equal to head of e of expert, true, else, false. Now otherwise, what we're going to do is just true. This I probably have to borrow. Okay, so now what we can do is we can add another test case in here where we can say sim f list blank, and then what did we say was the head of a blank symbol? Sim, and then we want this to be true. Oh yeah. Let's try it. Cool, so that worked. So now what we want to do is say if I called this f or something else, this will get false. Nice, and now we want the list case where we want, oh yeah, I keep forgetting these commas. So now I want this side to be f of x. And we want to say, since this is a list, its head is f, and so we want to match only if f and there match. So this should be true, but then if I duplicate this and change this to g, we should get false. Okay, so we found a bug. In case 10, we need to print oops. Oh, I think it's because we didn't change in here. We need to add this logic where you copy this in. Where does this go? This goes to this one. Cool. So let's try it again. Nice. So now we have head matching, which is pretty cool. So the next crucial step is to introduce new pattern objects. New pattern objects that are the most important, I would say, are going to be blank sequence, which allows, it is a pattern object that can stand for any sequence of one or more Wolfram language expressions. Okay, so this is the case where you have like uh, this A, B, C, and you want to match let's say, let's just write it out. List deck of F, and then the next thing will be this special one called, well, I guess it will be sim of blank sequence. This isn't exactly correct syntax, but, you know. Okay. Let's see. Well, we have two roads that we could take here. First, we could try to do just blank sequence, or we could introduce the idea of named patterns. I think maybe I'll go with named patterns. Okay. We want to So what I'm making a helper function so that I can get rid of this duplicated code that happens both here and here. So first I'm asserting that it's a list because if equal to p. Is that how you do that? Yeah, that's how you do that. Needs a list for p. Then we want to assert that. Do we want to assert anything? I guess we could assert that oh yeah, and this goes to bool. And here all we need to do is return is blank match of e of expr and p. Same thing for here. Cool, so that's useful. How long have we gone? Why is this thing bugging out? 38 minutes, that's not long. Okay, so the next steps, I decided we're going to do named patterns because that makes, I think, the most sense. All right, so named patterns are basically just a little addition to these blank h things, and effectively it's just adding this first part to it, x. So all this is remember our trusty full form is the most important function I feel like in Wolfram, is that now we have this x which gives it a name. It says this is basically a named pattern, but it still stores the blank object in its second argument. So we're going to try to generalize the case where all of our blanks can be named. And what I'm going to do, I think, let's see, what do we want to do? We probably want to introduce the idea of the matching being more general than just returning a bool. Well, that's useful. We also may want to know what is the transformation from this pattern, a set of rules that matches the blanks to what they actually were. So that would be like, if it's true, it needs to insert right. So let's see. One thing that I want to do is I want to take a pos, which is a vec of u size. And so this is its position in the thing. So what we need to do here is we need to do I. And the position is the position in the pattern or the position in the expr. For now, it won't matter, but when we get to sequence patterns, it will. And I think it's going to be the and so oh okay, so now we have our new position. Oh yeah, we don't have Copilot. All right. All right, whatever. Can't be the default format. Um, cool. So let me just think about. Basically, what we're building up to is we're building a map that will tell us for what positions of the blanks. So basically, it's a mapping from. Okay, so I'll just write it out in English. What we're doing now is creating a map from blank from the positions of the blanks in pattern to the expressions they matched to. Okay, so that sounds pretty good. So let's let pos map mute equal hash map new and we're going to add that as an argument to here. Yeah, so we're not doing named patterns yet, which I think is okay. So pos map, which is a mutable pointer to hash map of vec of u size to expr. Cool. And so we're gonna rename this function. I'm gonna duplicate it, and this is just gonna be called blank match, and it takes in the pos map. Should it though? This might get messy, but we're gonna see what happens. But here, for all the true cases, for both these, we need to do pos map dot insert. Oh, but we need the position. So we can do it here instead of that whole thing. So why don't we do that? I think that's not so bad. So if but here, and we'll need to put true here. And then we want so our position map, and then we want to do the same thing here. So we want to copy this. And here, is that correct? Yes, that's fine. But I feel like my formatting is messed up. Okay, so we're gonna Jesus. Expected semicolon? Bro, where are we at here? I'm doing all this. So that's fine. Then this conditional goes for this. But for some reason that's no good. I'll just write it by hand. So I don't see what's wrong. I think we but it's not formatting, and that makes me very suspicious. Let's see what happens if I try to run it. I love when they do this where they have like the exact same thing. Wait, was that the same thing? I don't know what happened. That was weird. Okay, now we're getting to the good stuff. Yep. That seems like the right place to do a clone. Same here. I don't care. Oh, I guess a lot of these probably should just take pointers. I'm passing around ownership, but I don't really mean to do that. Well, I don't care. And I want to print out the let's do this too. Uh-oh. Actually, that's an interesting one. But I think that's actually okay. Okay, and that's perfect. That's what we expected. Okay, so now I want Okay, so now I want to try a nested case, and I think I'm going to be a little naughty. And I'm going to go to here, and I'm going to yoink a little parser for us. Grab this code. So C add pack. Put this here. Then we're going to kill this code, this code, this code, this code. This is just going to be simple. What happened? Okay. Extern create. Cool. So now I should be able to do. Oh, and then we're going to make a function. And this is going to take an S of type pointer to string and return to expr. And we say expr parser expr s dot unwrap. Okay. So now I can just write my S expressions how I want. So I can say expr of f of a of b expr f blank. And now what we want to see in the map here, first we want to see a true. And then I want to put a here just to make sure. And I feel like we already have these cases in here somewhere, but now I like my easier way of doing this. Now we can run this thing, compile, compile, compile. Right. Of course. So that's a problem. We'll need to debug that. Alright, so where were we at? We had a bad test case failing. And what we were hoping to see is okay, so let's think about what happens. I'm gonna zoom out. I feel like it wasn't that bad. YouTube lets you zoom in. Okay. So the first thing that happens when we give it what we're working on right now is f of AB and matching with f of blank. Okay, so we start off and we get these both lists. We say, are the lengths equal? They are equal, so that's okay. We say if PS0 equals blank, which it doesn't, else we iterate them. Then we go to F, and we want to print position X for pattern. Let's run it one more time. Yeah, so here this should go in there, and then is blank matches must be returning. How do we do this debugging thing? We should learn this thing. Okay. Stop that. Whenever this is called, and then I want to be here because we expected this to. There, I'll put it there. Oh, but we need to disable all of our other guys. What? Try it again. What did I do wrong? Where did this come from? Did I just print out? Oh yeah. Okay, I'm back. So what are we doing? So this should be fine. So we should be able to. We want to step into this. Right? Don't we want to step into that? Oh, this just clones. Oh, I see what that did. Okay. So now where are we at? We're at here. So we're at the list arm. So now ease is this. Oh. Okay. So what we need to do is we need to make this part before this. So okay, so let's comment this out. Comment one of these out. Then we can do this. And then I think we should be able to just take this, put it in here. Okay, so now stop this, run our tests. Cool. So now at position 1 in our thing, we have a whatever. Okay. That's pretty good. So let me just re-enable these all to make sure that we're all good. All right. So now I think I'm going to make a function called position map replace. So function pos map replace. Traverses the expression, and whenever it hits a position in the tree that exists in pos map replace. And is there a case where you need to do this depth first? I feel like no. So what would that be though? Maybe you do have to do a depth first, because if you have So the full form of this looks like what? And let's make sure this returns true. That's good. Right, so this looks like blank, blank in our S expression syntax. So we should try to figure that out. This is our other code. So if I write this, I just want to make sure that I understand what this thing might look like. I guess that's totally fine. Cool. All right, so why don't we just do it? Now we're going to add another thing to my match that is the named map. And this is also a mutable hash map of expr to expr. And then wherever we see these conditionals here, we also need to say else if ps0 equal to sim pattern. So what we're doing now, and say is the idea that we can have these forms, which instead of inserting into this position map, insert the name and so let p name equal the first argument of it, so this is going to be p1. And I think we need to do this. I forgot, but I think we need to do that. Then we need to let b equal ps2. Then we want to do if is blank match on e b, then named map dot insert, and we're going to put the entire thing in this. We're going to put in pattern, and we're going to store e. And what is e? E is nothing, right? And this is not e, this is expert. Okay, so this case is the sim list. So what we want to do is we want to add one. Oh yeah, and we want to do this with named map. I'm going to put in mute named map. Okay, that sounds good. Now we want to add a case where we just have an F, and then we have a pattern X blank. And we want to see, we also want to print out the pos map and the named map. But I'll be cloning all over the place. I'm not good flying. Yeah, no, this is really stupid. We should not be doing that, but whatever. No, wait, I should do this. Cool. That's actually pretty nice. That's nice. We need to add that one more place though, which is here. So what do we need to do here? I think it's the exact same code. Except, okay, so what is this case? This is, cool. So I'm gonna commit this. See how long we've been going. 123. Alright, I'm gonna do a little sidetrack. I'm gonna open up my other code. I think it's in Matcher too. So this code has my get match that sort of works, but it's a total mess. Oh yeah, I call it parse. Alright, so what I want to do now yeah, so we're going to build this function. But with two of them. So up here, this one takes the pos map, and then we're going to have the, or I'm going to call it rebuild. And then this one is going to be, which takes the named map. That takes 2 scans though, but maybe that's fine. Okay. This code works for named map rebuild. So I'm just going to copy it in because I don't really care. And then what we're going to do here is we're going to have, and that's going to both position and name. So this one needs to take a position though. And it doesn't need to be mutable. Let's return the answer. So that's still the same. Right. This is still the same because if this was the case, this base case already gets eliminated by here. So we need to just change that to boss. We can copy this, except the only difference, let's do um, oh yeah. Jesus. E push I, oops. Then we want to do and it's just going to be pos map rebuild, pos map build, new pos e
in the pos map, which never changes.
All right. Oh, but we're not getting that. We're getting the pos. Oh, and this should actually probably be called pattern. Just to help my mental. Then what do? We new e dot push new e. Then we return okay. So this is going to take pos, or is it? I don't think this recurses, so that's fine. So this is just going to take an x, we'll call it pat for, and then a named map, and a pos map. Oh, and so it doesn't matter which order, I think. So we'll just do and then we're just going to return and then what we want to do is we want to add an assertion down here. Rebuild all of pat name map pos. That's perfect. So let rebuild x equal this, and we want to assert that this rebuilt expression is the same. Oh, and this needs to be, this pat needs to be what? Needs to be the same as x. Oh, right. If I think I need to do star here. Cool. All right, that's sweet. So now what we've done is effectively we've done pattern matching in its fullest form with just single blanks, no sequence patterns, and we have built the infrastructure to store what matches occurred in the process of finding the match, so that we can rebuild it later. So that's pretty cool. All right, so I might do more later. I feel like that's a good, good stopping point.